Good afternoon. Please take your seats. So let us begin the penultimate session of today's events. We want to hear from Professor Gopal himself about his journey in the Indian Institute of Science. So this is the session, and the session will be followed by the reminiscences. We'll have a small high tea break in between. To chair this session, I invite Professor Anand Suresh from the Department of Mechanical Engineering. He's a professor there. He was our divisional dean, former divisional dean of the Mechanical Sciences, and chair of Biosystem Sciences and Engineering. He has been awarded the Shanti Swarup Bhatnagar Award, and his interest lies in topology optimization by biosystems, compliant mechanisms, and MEMS. Professor, please.
Thank you, Srisha, and good afternoon. I think we are here for a celebration of distinguished career of Professor Gopalakrishnan. And Srisha asked me to say a few things about Gopal that I know, that I've seen my association almost ever since I've joined IISc. I've been interacting with Gopal. But generally, if you look at our faculty, our IISc faculty, the arc of their career, if you look at it closely, we see some unique characteristics. So I was thinking about, if you look at the arc, we'll hear from him about his journey. What are the unique characteristics? The first thing I would see is that Professor Gopalakrishnan works on spectral finite element methods. Right? Whenever you get a signal, there will be several frequencies there. So which frequency will have the largest amplitude? Look at the signature of that. So what are the characteristics? Which one, which mode shape or which mode will be dominant in that? Any of us who had looked at his CV, you would say that every frequency is very top amplitude. Whichever we look at it, any list you look at it, so every list is long. And if you look at publications or citations and grants, number of PhD students who graduated, it was like 35 or 36 years, been in IISc for 28 years so far, 97 to now. And that is much more than the average of IISc faculty, graduating students. I think many of you are here. So we look at the books, we saw the list there, that is also long, right? And recognitions, I will not even go into that. It's a long list there. And collaborations, and also service that he has done to the institute, that's also a long list. And everything, anything you say, I think if a structure that is doing structural monitoring, is very difficult to control. Everything is dominant there, not one, right? That's the character I see. The other way I look at it is that in the animal kingdom, there are a few species which have to be working all the time. They have to keep their metabolic activity high. Otherwise, they cannot keep up their temperature high. I think Professor Gopal's blood is also like that. If that is not kept at certain level of intellectual metabolic activity or academic metabolic activity, he will not be satisfied. That's what I've seen. He's very restless after every time he has to do, and that's the result of all these long lists. Are the role of what played a role in this long list is actually this. I think he always wants to work, and I was not here when he joined in 1997. I don't know how he worked at that time, but I think who have observed him would have not noticed any change. He's probably doing that actively 1997 to now, and he'll be with us for 5 more years as honorary faculty. I think it will continue, and that's what I find. And as about service, right? So as faculty we do many things, and he has done all that faculty member can do in IISc, including service. A good citizen, that's the phrase I would use. And my own association, I should talk because Risha asked me to do it. Even before I joined IISc, I had an interaction which Professor Gopalakrishnan might not remember. It was IISc conference. He was the technical committee chair at that time. I think it was just 1999 or something like that. That conference got postponed, right? So I was at UPenn at that time. I had sent a paper to that conference, and he made me, format it multiple times because I was not adhering to the page limit and word limit and two column that. It was very very meticulous. You don't remember you did that. That was before I joined IISc. So I said, okay, when I came back, I should see who this Professor Gopalakrishnan is. Right? He was very particular. The conference paper, but he wanted everything, as per the rules, right? And then after I actually met him before coming here, that was in Pittsburgh. The planes had struck World Trade Center, two buildings, and we were stuck in the ASME conference in Pittsburgh. And that's when I think he was stranded for some time over there. And that's when I actually first met Professor Gopalakrishnan. He was trying to talk to my advisor to invite him for, I guess, IISc conference. That's when I first met you, and you may not remember that also.
I do.
Okay, anyway, so I think that's how it started. After coming here, we work very closely because there is this society, Institute for Smart Structures and Systems, and Professor Gopalakrishnan actually played a big role in that society. He served as the president of the society also. That many of you in the department also might not know. The amount of work is put. There used to be two national programs, NPSM and NPMAS, National Program on Smart Materials, National Program on Smart and Microsystems. Those two, I think, he played a big role, handling many projects, involved many of us in that, and monitored. Like I remember that conference, the way he did, that's how he monitors things, that everything has to be done in a certain way. And within that also, I've seen in the society the way he's involved. Even now, he is the editor-in-chief of the Journal of IISc. Like, any journal published in India, one has to do a lot of hard work to make it stand. He has been striving towards that. And again, there I see restlessness in a positive way. He kind of revamped that journal, got international editorial board there, and chasing people and getting special issues and involving two of his students as social media editors and many, many initiatives to make that journal stand tall and be distinguished. And within the institute now, he's also looking after this Axis Bank Center for Mathematics and Computing. And I remember being in the main building when discussion came up who should take care of it. When Professor Gopal's name was suggested, we said, oh, that's good, he will take care of it. That's true, it's doing well. Nobody has to think about how Axis Bank Center. Now I think maybe he'll continue or somebody has to follow his footsteps. And also within Bangalore, there is INAE chapter of Bangalore. So he's taking care of that also. We see a lot of activity. When Professor Gopalakrishnan is in charge of something, we see that activity, that metabolic activity I would call it. So that is Professor Gopalakrishnan. In whichever way you look at it, he has done it. In fact, he has done so many things in his research that singling out one becomes very hard. I was just looking at the monitor in the lobby where they put, important works that he has done. That list is also long. I could not read them. Font is small from far. So everything is long. It's sometimes become difficult to say, oh, this is what I would like to highlight. There are so many things. And I also would like to tell you on a personal level, Professor Gopalakrishnan, I don't know, many of you know, he's a very good cook. And I heard about, from his wife, the chutneys that he makes, South Indian chutneys and powders, and the upma he makes. Many of you might not like upma, but I think when he makes it, I think you might like.
Tomorrow morning, I'm so sorry.
So I hope to taste his food sometime, but I think now he has a feast for us here, intellectual feast. And Professor Gopalakrishnan, congratulations on your distinguished career. You'll be with us for 5 more years. And just like you do structural health monitoring, I'm sure you're monitoring our health as well. We wish you long life and all the best. Thank you.
Thank you, Suresh, for this wonderful introduction. I think some of these are exaggerated. I am not like that. So it's very hard to present my journey in a short time. And with so many activities, I said, both within the institute, outside institute, internationally, so many things I have done in the last 28 years. So very difficult to uh, concisely put in less than an hour's presentation. So what I have done is, what I am today is because of my students. I had an opportunity to work with some really wonderful students, and whatever contributions you are talking of me is not of mine, it's of my students. My main duty was to motivate them, and that is the bigger part. Maybe uh, there is something in me that people who work with me got motivated, and they were able to achieve uh, whatever I am today. So what I have done is, till now I have graduated 32 PhDs and about 27 masters, both ME and MSc, MTech engineering. I would have loved to present all their work, but that would go and you will get bored. So what I have done is, concisely I have requested to put one chart to summarize their entire PhD thesis work, to just to give an idea of what they have done. And that's all I can do, even though I would like to have, and mostly of my PhD students. And just one work which I thought was very good about my master student and one of my PhD postdoc student. And that's all I could do with this. Since this whole thesis has to be put in one quad chart, I came to know about quad chart when I did these ONR and Boeing projects. They say that 1 year's work has to be put in one quad chart. So he said you can convey everything in that. And that's when I learned how the importance of the quad chart. Otherwise, we don't know. All these multinationals and corporate people, they work that way. They have no time for slides after slides presentations. So what I have done is I have put all my students' work, PhD students' work, into a kind of a quad chart, to just give what they did without going deep into that, so that you have an idea on the length and breadth of the work. And most of the work I have glued to wave propagation. I have diversified into many areas. And even when I diversified, there will be some wave component there. So I have not migrated in my area to propagate this. But there are many aspects, new aspects that we have brought in within the domain of wave propagation. So to start my journey, I joined IISc on November 27, 1997. So it's about less than 28 years. So I finished my PhD at Purdue, did my master's at IIT Chennai in applied mechanics, and then I was a postdoc at Georgia Tech for about 2 years. Then I returned to India. I was teaching 2 years at IIT Chennai from 95 to 97, and then came here. My professor who taught me waves is Professor James F. Doyle. And he's an Irish professor who is a thorough experimentalist. So when I was the first theoretical student of him. So he was a little upset that I didn't do experiments because I'm not a good experimentalist. So I worked on a NASA funded project that was on bird hit aircraft. And those days we didn't have the computational power. So we used to have this UNIVAC main system at Purdue, where some very high performance FE simulation used to take 17 hours for one data. And afterwards, that is found not useful, again another 17 hours modified. So it was taking too much of time. So this NASA people said, can we have a simplified model to do this analysis? So that's when we invented what is I performed later what is called the spectral FEM, and that's how it took off. So this is an average analysis, very fast analysis. So what you used to take 17 hours, it used to take 17 seconds, and that way we can do all modification. Although we don't get very detailed analysis, the error was about 15 to 20%, but the trends were okay. So we used to get some ideas because of the lack of computing power those days. So that's how it started. So I would call my professor Doyle, and his advisor was Taylor. So Taylor series is infinite. I was the first term, and all you students are the subsequent series, and this series has to continue. Okay, so that's what I say, because coincidentally his advisor was Taylor, so the Taylor series continued. So that's what I would say that. Okay, so I have mentored about 32 PhDs, 6 MSc engineering students, and about 17 ME MTech students. I was an associate chairman in CSSE. That's where I worked closely with Professor Sima. He dragged me in into it. That's when I just became an associate professor. Immediately, Professor Munjal said, you should go there. Then from there, I was given, Sima gave me a job of looking at intellectual property. There was nothing called IP there. So that time, Govardhan Mehta was the director, and he said that we need to find what is called IP cell. Today it became IP tel. And that is the time when I worked with the late Subbaraman to write the first IP policy of the institute. And still it is continuing. So I founded the IP cell and then started the IP process, which is now really doing very well. So then I was a chairman of the Aerospace Engineering, 2015 to 19. Thanks to Professor Kamanyo Chittopadhyay, he was the one who asked me to take over. And undertook several funded and consultancy projects over the years. So let me go through the PhD students. So all the slides are very busy because I'm concising everything in one slide. So I have split up into 3 or 4 phases. That's my first phase as assistant professor. So 97 to 2004. So in the year 2004, I became an associate professor. So I want to show you what I did and how this productivity of mine is there in these 3 periods. So I worked initially on wave propagation. That's what I came with some background, and I worked on metals. So I started doing in composites and functionally graded materials, and published about 26 papers during that period. That is between that, and with only 2 PhDs, and 2 were really outstanding PhDs I had. So my first student was Roy. So that time when I came there, we were doing on metals. So we developed this spectral FEM to composites. Because of anisotropy, the solution of equation became very complex. Determining the wave modes were very difficult. In fact, my advisor gave up on this method because he couldn't solve this complicated characteristic equation to determine the wave numbers. And we sat down and we found out how to do that. So did that for composites, how the wave propagates. And one of the things that Roy did was how most of the things we do in composites are symmetric laminate composite. So how will the unsymmetry, one of the people always avoid unsymmetry, but unsymmetry has very good properties in waves because it can delay the wave by 40%. The speeds gets reduced by 40%, especially in the context of impact. It will be very useful. So he was the one who did this and formulate efficient element for both the elementary higher order rod defects with defects, multiple defects. Whenever there is an impact, the delamination will be in the bottom of the base laminates. So how this he entirely modeled this and the efficient techniques to do that, develop very simplified model, which is one of the very highly cited papers even here. So basically, you have an element with a built-in delamination, horizontal delamination, and the vertical delamination was worked by Srikanth, I remember. And this is still very highly cited paper where you can just plug in this wherever you want. Because if you take an FEM, when you have a beam element, when you put a crack, you can't use a beam element. You have to use 2D elements. So now with 1D approximation, we are able to build the 2D models. So that's very important contributions that he made. And he also worked on the wave propagation in composite tubes. How basically the equation is very complex, what happens to that, and that is very important complication. So this is the first time we took look at the how wave propagates, and one of the important things which Roy did was how you can use it for control the structure. He developed what is called active spectral element with piezoelectric layers, and how you take the error sensor and do a closed loop control, and how you can use this with very little. So there is no state space modeling that is normally used in control. So he used everything under the spectral FEM umbrella. And the good thing is he had some 7 papers, and each paper had 2 or 3 papers and 8 chapters, each paper. So he published close to 18 papers from his thesis. This is a very active area. So whenever we sent this, all in very top journals, like IJSS, Sound and Vibration, and those kind of journals. And the next outstanding student I had was Abir. Abir was our own ME. He was a topper. His name is there in the roll of honor. After ME, he joined me as a PhD. So Roy worked on 1D models. And for the first time, we attempted the 2D model, the half space model with Roy talked in the morning, and on the graded material. So where you used to get inhomogeneous equations, solutions became very tough. So we came up with new methods. The other problem I told was to get the wave number computation. So we came up with 2 different approaches. And one of the approaches is the polynomial eigenvalue problem was implemented after we published the paper in MATLAB today. So that's the huge contribution that Abir made to this. Is very outstanding. He just took 2 years and 10 months. I delayed by 6 months for his PhD thesis. And he is another outstanding student who did the complete 2D. He come up with, if you look at the Lamb wave equation even for metal, it's a transcendental equation where you use what is called Helmholtz decomposition to decompose the whole governing equation into scalar and vector potential, and used to get this. Such decomposition is not available for composites. So he came up with a new method using dynamic stiffness to get the complete Lamb wave propagation, Lamb wave modes, as a function of the laminate orientation, whether it is 0, 90, 45, etc. So that is one thing. And because we had a very simplified spectral FEM model, we could find what is a Rayleigh wave. Even the Rayleigh wave equation for composites is very difficult because we have a spectral FEM automatic solution. We can get how the Rayleigh wave propagates on a composite, on the interface, the Stoneleigh wave between the layers. So we could compute all of this through his work. Again, he published around 15 journal papers. And when we accomplished this, both put together, I told to both of them, let's author a book on the spectral FEM, which is first of its kind. And this is the product of that. So that's how it is. So from 2003 to 2007, that's when I was an associate professor. I got an out-of-term promotion as associate professor. So I continued to apply new damage measures in SHM, which was started by Roy and Rabi. And then we had some problems with Fourier-based spectral FEM. So for spectral FEM, you need a transform. So typically, you are using Fourier transform. But it had what is called, because Fourier transform is periodic, it has to cut down at some, when you impose some boundary, then you had what are called signal wraparound problems. The signal doesn't die down within the chosen time window. So we were looking at whether we could use another transform. So we started using wavelet finite elements. So where we used a wavelet transform, but there are many wavelet transform. So we used Debenchi's wavelet transform. That's where my student Meera Mitra, who worked as a MSc engineering student, continued to do PhD with me, and she started working on it. And I also start working in smart structures and structural health monitoring. And thanks to Professor AVK, who introduced me to both of this, because he asked me to participate in his ARDB project on SHM and smart structures. He introduced me to some of the pioneering work that Anjanappa did in University of Maryland, Baltimore that time, to get me interested into this. And I also worked in failure theory of composites. Our staff, Narayan Nayak, worked with me. And then I had some ideas about working on fluid finite elements in a different way, because I briefly worked for a few months in Engineering Mechanics Research Center, where I was developing this fluid software. Unlike the regular finite volumes and things like that, I wanted to use fluid elements in Lagrangian frame of reference. Why people have not used it, what are the problems, and can we overcome it? So I worked it. I had a project with Crane Software those days to develop that. So started working on it. And I started something called super convergent finite elements. It is like a finite elements, but in time domain, using the same concept of spectral FEM. And during this period, I've published 53 journal papers and 3 PhDs graduated. So one of the persons, he's here, Devi Prasad Ghosh. This is when I got into magnetostrictive material. People were using only piezoelectric. And those days, magnetostrictive materials was typically an actuator material. It was not used for sensing. And we wanted to see whether it can be used for sensing. So we started modeling that. So different element formulation and how do you model the damage. And so he did a lot of this work, development of the constitutive model, because if you look at those days, there was only one company called Etrema, which made this magnetostrictive material in bulk form, rod form. And magnetostrictive material is the material made from the rarest of the rare earth, that is terbium, and is an alloy of iron at certain fractions. And it had an enormous actuator property. That means it can generate kilonewtons of force if you have a block force experiments. And the property that was given by Etrema, if you look at it, stress versus strain as a function of magnetic field was highly nonlinear. And these were given only for certain magnetic field. And it cannot be used for a range because no work was done those days. So what he did was he developed a different constitutive model, whether it is linear model, linear uncoupled, linear coupled, non-linear uncoupled, non-linear coupled. And he also those days those days when we didn't know what is AI, he uses artificial neural network to actually come up with the constitutive model. So these were some of the initial work that we did. Based on this constitutive model, he developed a series of both conventional FEM and spectral FEM, and generate a lot of data how this works as a sensor, especially in presence of damage. So that is the first time we are using this material as a sensor that could be used, because the actuator performance was well documented and people used to know. Then came Meera Mittal. As I said, she worked on the wavelet to avoid uh, the signal wraparound problems that is normally associated with Fourier transform, and developed a series of wavelets for both 1D and 2D, developed new damage measures. Then she also introduced for some certain kinds of damage where solutions were not available. She did something on perturbation methods, based methods analysis, and simplified wavelet based modeling for detection of damage. And she also attempted to do this damage modeling on nanostructures, especially carbon nanotube, where the multi-wall we model the van der Waals forces through springs and develop this shell type wavelet spectral FEM, and see how the wave propagates as a function of the van der Waals interaction, number of walls. Here we didn't use any MD or any kind of sophisticated model. We simply used beam type models and compared the results with MD type simulations. And we found that there was about 10 to 15% error based on our model. And based on this, she, uh, sorry, uh, what is the pointer here?
Top one.
This one. Oh. So we made this book, which was published in uh, CRC Press, and this is one of the best sellers. Now the publishers are asking us to write the second edition. And she published 12 journal papers in this area. So that's why I said my first few students were outstanding. Most of my papers were coming from these first few students. And it is not my papers, it is their papers. Then Naik is here, not here. So he was working basically with AVK, and that time AVK was retiring, and he said you should take over. I had no idea about composite, especially the failure theories, and so it took me a while to understand the failure theories. And that time I knew that what does the failure envelope means. So here what happens is in composite, most of our design is made from Saiwu criteria. So the Saiwu criteria is not a symmetric envelope with respect to your coordinate axis. So you have a long tail here and small regions here. So basically this is, so here you will have the fiber buckling, the fiber crushing, and there is compressive load and the tensile load, and this long tail. Is it normal to have this? Because basically Saiwu is a curve fit based on uniaxial data. It is not based on biaxial data. Even today they use this for design. So, what the thought process is not Kandagal, and he joined me. And he did some remarkable work. So initially he started putting piezo patches. We constructed a scaled down model of a Navy platform, and then we put different, so there are columns and beams. With patches I can control the vibrations of the plate, the slab on it, but I can't control with columns. So columns we needed stack. So putting the stack was very difficult. So he came up with a very new concept that the stack should be able to work as a patch. So what he did was he just kept the volume same. He expanded and kept expanded the stack in one direction and contracted so that the volume is same. And we wanted this kind of a stack so that it can be mounted like a patch anywhere and work. It's called a multi-layer actuator. But there was nobody to make it. So normal will cost $1,500 stack. We paid $5,000 four times to fabricate this APC. And when we got that, and we had some really outstanding results. And this is now filed for a patent. And we also worked on nonlinearity. So this is my last slide. My output, so 32 PhDs, 20 MA and Tech students, 6 PhDs are continuing. I have totally of 245 journal papers and 180 conference papers. I have 11 books, the 12th one is coming. 15 book chapters and 5 proceedings edited. So these are my books. If you look at it, this is a new book that is coming. I had a pleasure of writing a book also with Anand Suresh here. This is on microsystems that we wrote long time. And this is one for the Indian edition, which is adapted by VTU. And based on it, the publisher asked a US edition to be made. So this was there. And the more recent one is today that was released with Raj. So acknowledgements. First I will acknowledge my Guru, Datta Guru. Datta Guru was Guru to all. I was responsible to be here. All my PhD students, former chairman, Professor Mukunda was there when I joined here. And all other chairmen, Datta Guru, Raghunandan, Bhatt, Ghosh, and my present chairman, Joseph Matthew, who made my life very simple here. My former structures colleague, Professor Ramurthy, Professor A.V.K. Ganguly, Professor V. Mani. Mani is always a part. I consider him as a structures, even though he is not. My former colleagues, Professor Reddy, Lakshmi Shah, Karthik.
Gopi, I'm not former.
Yeah, you are here. Professor Deshpande. And I like to thank my office staff whom I worked. Rayappan is retired, he is not here. Narayana is retired. Late Revati, who was here when I was the chair. Somshekar and Anusuya. And my Axis Bank Center, Raghavendra and Vivek. Outside the department, former directors, I worked with Mehta, Balram, Anurag, Professor N. Balakrishnan, Associate Chairman. Deep chairs, Professor Munjal, Srinivasan, Professor Chattopadhyay, Professor Vikram, and Anand Suresh. The current dean, Professor Suhas Satyam. Professor S. Mohan, I worked with him both in IISc and as a SID resource executive for almost 16 years. With him and with other chiefs. And Professor Simha as CSIC, and Professor Vinay, who was my co-guide, and I worked with him on IISc. So, and my other mentors are Dr. Atre, Dr. Upadhyay, especially for nominating me for the member of RC. Professor Venkateshan, I worked from 2004 to 2018 in ARDB, 2017 in ARDB. I worked with a variety of ARDB coordinators, including Venkateshan, Professor Santosh Kapuria former director of ICRC. He was the one who nominated me to, ICRC and INAE for nominating me for the governing council, the previous governing council, and also aerospace sectional committees I serve. And currently I thank INSIS, Indian Structural Integrity, and I work with Vikram, Sundar, Ravi Prakash and others. And Deepa Srinivasan I worked with very closely when I was in Pratham Center. So my collaborators, there are a huge number of people I have listed. All of them have made my life very good, either in terms of funding or advice, or whenever I visited, a whole bunch of people who made my things. And I think I put Raj in the first name because he's very favorite to me. And there are so many others. For example, Massimo, I wrote a book on computational techniques in health monitoring when I visited him. So it's very. I work with Fabrizio from University of Christian Bowler. So many people. So I sincerely thank Shockwave Society and Jagdish, Shrisha, my present student. I don't know all the names of your students in your Shockwave LHSR who made this workshop and this event possible. I sincerely thank. And finally, my sincere thanks to my late mother, my father. My father is 96 years old. He's still living. And my wife, Anu, and my children, Karthik. Karthik is now finishing his PhD in US. My daughter is started her master's in US. They have given up on me because I was always there 7 days a week here. So that has taken a beating, but they know that I like this, so that's what helped me. They understood me. So thank you all for making this happen.
Thank you, Gopal. Actually, Srisha was sitting there, 5 o'clock, but I thought today we should let him speak up. Because he has given so many talks that we can stay here 15 more minutes. Thank you, Gopal, for taking us through your journey. Congratulations once again.